Good afternoon and welcome back to the enclosure. I want to thank you for your patience. This is a long overdue update. Life has been quite a bit of a roller coaster actually over the last month. Lots of stuff's gone on. I've had a large learning curve on the electrical. I am running a lot of 24 volt and some 12 volt DC lighting. Actually, I'm running a huge amount of 24 volt lighting, but most of it has its own driver, transformer step down driver. So for instance, this is one of my ceiling gimbal lights, LED lights, and it has its own driver that steps it from 110 volt AC down to let me just check. Indeed, this is going to 27 volt DC, 20 to 27 volt DC. So I guess that is based on the dimming potential. Anyway, I have a lot of lights that don't have their built-in drivers. And basically, I think I've talked in the past about how I'm doing these surrounds on the ceiling with sort of an LED light trough. Then I have LED lights that are underneath bathroom vanities. I have a whole bunch of floor spots that are going to go near the wall and sort of shine up against the wall as a architectural element. And then I've also got some on the stairway, on the treads to illuminate during the night. Anyway, I've got enough that it started to make sense to have a centralized power source instead of running a whole whack of tiny or small driver transformers. And by having a centralized set of larger transformers, hopefully my standby losses when everything's off will be much lower. That is something that I have in my notes. Obviously it was told to me or I've read it somewhere, but I was not able to find where I found that information. So because I'm running centralized DC, I had a big learning curve on what's required to send DC throughout the house. And basically the rule is if it's under 96 watts, it's not that important by electrical code. Once you get above that, you start getting into what are called class 2 and class 1 electrical circuits. And I'm going to be running some transformers that are 480 watts. That are broken into a couple of circuits. That definitely got me into class 1 wiring. And I haven't done class 1 before. So that was the learning curve. It involved having to rethink how I did the electrical boxes. So for instance, here's a box that used to be a 2-gang plastic. But in order to do class 1 wiring, you have to separate the low voltage DC from the higher voltage AC. And that made things a lot more interesting because now, even though this is only going to have 4 conductors in it, I can't borrow the excess 2 conductors that are allowed to service this side of the bay. And so the reason this is loose is because step 1, I replaced the 2-gang plastic with this 2.5 inch deep 2-gang metal and put in this partition plate. But now my box fill on the 110 volt is too high for a single 2.5 inch box. So now I'm going to have to step it to a 3 inch deep box, and they only come in gangable boxes, which means it's a single gang that you then have to take a partition plate out and keep joining them up if you need multiple gang boxes. So that involved a lot of planning. Before I could figure out what my box fill was, and therefore my box requirements, I had to figure out how to actually wire up these fixtures in a DC fashion, including my computerization that I'm going to be doing. And so that is what this monstrosity over here is. And it's taken some time. I had to wait till I got the components from mail order. But basically what I've got here is I have both a 24 volt test circuit, which is doing 3 different circuits. And then I have a 110 volt circuit that is also computerized. So on the 24 volt circuit, I just have a cheap transformer that I use for testing that does my driving. And this is actually the computer. So this is what talks via Z-Wave technology. I decided to go with Z-Wave because it's a lot more approachable than, say, I think there's something called Phase 4 or Force 4, I think it's called. That gets into heavy bucks, professionals, highly technical professionals coming in and setting it up. And I wasn't interested in that. I like to play with stuff, and I like to play with parameters of the settings, figure things out. And so I decided on the Z-Wave technology, and then I decided to use HomeSeer as my Z-Wave controller. So I have a HomeSeer computer. It's at the suite across the street, and it talks to this building via Wi-Fi and a cable I have. And then it talks to all of the Z-Wave devices I already have in the house. So let me just put you down for a sec. I think I can do this without dropping you. And I can do this wonderful motion steady handheld. And I want to thank Andre from AF Productions. He's a friend of mine who does videography for various TV shows and whatnot, and he's donated one of his older handheld steady sticks, and it's made a huge difference to the quality of the videos. So I've got a power supply, 110. I want to plug in my 24 volt driver, and what you're going to see is you're going to see a whole bunch of LEDs flash on when they first get power. And then we've got the 1 circuit, 2 circuit, and 3 circuits. So for the 1 circuit, I wanted to figure out how to do 3-way switching. So you'll see here, that one goes on, that turns it back on, or you can turn it off there and turn it back on here. There is a big learning curve on how to wire these up. They're not standard 110 volt wiring patterns. And what you need to realize, and it took me a while to figure this out, the switches are not carrying current. They're not carrying the 24 volt. They are just carrying a signal to this device to tell it to turn on, off, or up, down the 24 volt current to the fixture. And that took quite a while for me to get through my head. So that's 1 circuit that got figured out. And like I said, it took a while to figure it out. I had to get the right switches. These are 3-way DC switches, which are different than AC. They're actually certified for DC. I am trying to find, and I believe I just have found now after many hours of searching, these are toggles, which means there's an on and an off. But there's what's called momentary switches, where you actually have to press it down to hold it in that position and press it down to hold it in that position, and when you release, it goes back to the center. That will actually allow for dimming up and down. Right now it's just going to the previously set dim level, which I can control with my phone. I can turn all of this off just by going to my phone and saying, I'm using the home stair configuration, and we're on the first floor, we're in the kitchen, and we have one on right now, which is that, gone. So, and I can dim and set accordingly. So with the three-way figured out, I then needed to figure out the single switches. As I mentioned, I think I mentioned, I'm going to have 3 or 4 of these in the house, each controlling 4 circuits. They can control a multicolor LED, red, green, blue, white, and make all kinds of fancy little colors out of it. Or they can control 4 individual circuits. And I'm going to be using the 4 individual circuits. So as a test, that's that one there. And then we've got that one there. So again, it took some time to figure out these are just activating the instructions in the module to dim up, dim down, turn on, turn off. So with the DC figured out, I then switched to AC. And again, I want to control all of the lighting circuits in the house, basically with the computer, with a smart phone, tablet, you name it, with devices that are in the in a light switch that are called scene controllers. So they have 5 different buttons, and each button can activate a different series of lights or an individual light. It can be made to make the lights flash if there's an emergency outside, that kind of thing. They're fully programmable. But the issue with even just standard non-computerized LED dimmers is that they're expensive. They're 40 to 50 bucks for a good quality LED dimmer. I think they're called pulsed wave dimmers. And I wanted to get away from having to have a specialized dimmer in every single light switch, because I've got a lot of 3 and even 1 4-way light circuits to allow for the convenience of being able to turn on the light at both ends of the hall, top, bottom of stairs, all that kind of stuff. So I've been searching on the web for some time for the right technology, the right Z-Wave technology to use. And one of the newer devices out there, it's called Zooz, Z-O-O-Z. And they have come up with a module, a smart module, that only has to be placed at the beginning of the circuit where that circuit receives its power from a panel or another part of the electrical system. So you only have to pay, and I think this is only 40 bucks, 45 bucks. You only have to pay for a 1 for every single light circuit, which is going to save me buckets of money. And then all of the rest of the light switches are these cheap $3, $5, $7 light switches. So that ends up making the system much easier to use, or to wire in. And again, there was some learning curves. The same concept here, where the switches don't carry current, the same thing is happening on the AC side. So things really got crazy compared to a normal AC 3-way or single wire up. The switches are only carrying a signal back to the controlling device. So this is just what I've got is I've got the LED that I previously showed you, the driver and the LED, plugged into a switched outlet, and basically, now I'm just using the dumb switch here, But if I go to the smart switch, I should be able to. Oh, there we go. I just wasn't pressing it right. So I can dim that up, I can dim that down just within that smart module. Now again, if I can find a AC momentary switch, and I believe they're a lot more common than DC, then I'll be able to dim from this side of the circuit, not just the smart side. So again, are we dimming? Yeah, we're dimming. It's just, so there's and it's flashing because I'm actually going too low. There is a minimum load, and the single small LED isn't doing it. But there's parameters I can set here that set how fast it dims up and it dims down when I press and hold the button. This is actually a momentary switch. I don't know if you can hear it. It's clicking when I press, and then when I release, it's going back to the center point. And that's basically what I'm wanting for all my switches. Okay, so with the AC and DC figured out, I then had to figure out where all the transformers were going to go. And then I had to figure out the fusing. So I'm going to unplug this because, and I don't leave this plugged in. This is an unfused system right now. And what that means is that there's no secondary protection in case the transformer goes wild and starts pumping out ridiculous amounts of DC current. You must have what's called an inline fuse between the transformer and the circuits. And this can be one of those cheap glass fuses that are on older cars or in your microwave or that kind of, your cigarette lighter connector charger for whatever. Or I am going with a little bit better quality and usability, but not terribly expensive. They're $5 to $10 a piece. A circuit breaker that you just press in. If it pops, you just press it back in to reset it. And so, thanks to Jonathan, my nephew, who has a lot more electronics knowledge and training than I do, he told me some things on email, and I was able to order my circuit breakers this morning. So what you want on a DC fuse and or circuit breaker is you want a voltage at or above the voltage that you're running in your system, and an amperage at or below the amperage that you're running in your system. And I was looking for a 24 volt fuse, and everything was either 30 or 50 volts. And it was like, well, that's not going to work. And actually, yes, it does. As long as it's the right amperage, that works. Now, don't ask me. I'm not an electrician, and I'm not an electronics expert. I don't know the theory or how that all works. But as long as if you have, and let me get my calculator out here. Let's say you have 150 watts of lighting on a 24 volt circuit. You divide the 150 by the 24, and it gives you 6.25 amps. That's the amount of current that you're going to be sending through the system. So in this case, I needed basically a 7 amp fuse or circuit breaker. So that's what I've done. I've ordered those, and they should be coming shortly. They'll go into junction boxes between the transformer and the circuits being fed by the transformer. The transformer itself must also have fusing in it. And fortunately, the better call, this is just a cheap piece of junk that I just use it for testing. But the more expensive transformers, the better quality ones made in North America, they have fusing built into them, both on the AC side and the DC side, where it will cut out if it goes over parameters on either side of the equation. And so I've got one here, I'll show you. I think you can even see the fuse. This is a magnitude magnetic driver, LED driver. And hopefully, can we see this okay? It's a little bit dark. I'm going to try to put some light on it with my cell phone here. Bear with me. Okay, that's better. And this was interesting because this is a certified, it's CETL and US ETL transformer. And I thought you had to have a partition plate between the AC and the DC side of the transformer. But you can use another rule which just says there's a certain amount of room between the two sides. So the DC side is the red and the purple, and the AC side, there's the ground, your hot and your neutral. They go out one side, the DC goes out the other side. I don't know if you can see it, that little black thing is the fuse for the two systems, like the AC and the DC. So this is a 100, sorry, I'm trying to get the shadow off. This is a 150 watt transformer, 24 volt, and this will be what I use in the kitchen. So this will feed all of the kitchen drawer lights, the automatic drawer lights. I'm getting those from IKEA, and instead of using the IKEA drivers, I'm going to use my own centralized driver. The soffit or the valance lights underneath the cabinets, and then also it's going to run the perimeter light in the ceiling. So what I wanted to do is I wanted to figure out a good place to put this. And so I'm going to have my kitchen sink cabinet here and a corner cabinet there, and I think I have a 15-inch wide drawer unit here. Over here I had a gap, well, you can actually see it if you look closely on the ground, the lines here to here, where it would have just been basically a cover plate across to join up with the cabinets that are coming down the island on this side. And I decided that would make a great little spot to put the kitchen power system. And I'll have basically, instead of this being a cover plate, I'll have it as a door. And so it's completely accessible and it's not hidden and all that kind of stuff. And so I've got a 110 volt supply. It's going to go to the DC AC transformer driver. And this is even a dimmable driver, so if I wanted just to have this for an entire lighting circuit, if I had a need for 150 watts of LED driving, I could just have a centralized dimmer that dimmed the driver instead of dimming the individual DC circuits that are coming off of it. And so off of that, I will bring a junction box. The junction box will have the circuit breaker, the DC circuit breaker, resettable circuit breaker in it. And then from there, I'll feed the various circuits that I've got. So that I think was a good way of dealing with the location. The other drivers that I have and transformer step-down drivers are going to be in the guest entrance closet, and basically they're going to be behind that beam. So that will this entire closet is basically, there's going to be a closet portion of it below, but above is going to be basically a utilities closet. I'm going to have my heating system manifolds in there. And then on the back side of this beam, and I've already started running some of the required junction boxes, I will have the AC supply to the DC transformers, and then the junction boxes that the circuit breakers are going to go into, and then the junction boxes that feed all the individual circuits. And this is where I've got all of my outside LED soffit lighting coming to. It's where I've got my Christmas light supply circuits coming to. So basically it's going to be a mass load of circuits that are controlled in that closet. So with all that done, then I was finally able to figure out the routing of all of the cables throughout the house, and I've got them all now drawn in AutoCAD because there's the saying, fool me once, shame on you, fool me twice, shame on me. Well, I'm on the fool me 3 times. I've replaced some of these boxes 3 times because I just haven't been thinking through the process, and I don't have time to be redoing work that I've already done. So what else can we talk about? I think that's about it for boxes. So I'm gonna interlace this video with some of the other videos I've taken. So we're talking about electrical, and I'm now going to talk about my approach to labeling and stapling. So I like to label all of my bays in all of my boxes on what circuit they are, and then in the case of switch boxes, I've got all of the switch numbers, so 68, 69, 70, and then on the top I'm marking what they actually do. And I've got an Excel spreadsheet that's got all of the circuits. I've got an AutoCAD that's shows where all the wiring goes. And then I also mark the individual cables to where they're going to go next, or where, in the case of, say, the end of the line, I mark where they've come from. But, so this one says it's going to S72, which is, I know, over at the French door exit from the dining room, and it's for the 3-way for the barbecue pit. Anyway, so that takes care of labeling. The next thing I like to make sure I do, and this is, a lot of electricians aren't going to really care about this, but it's important for the insulators, and that is when you have a cross bay cable, to make it as horizontal as possible. And what that does is it allows the insulators to slice the insulation so that it's going to fit tightly around here. If it's like this, it's a lot harder to get a nice tight fit, and that is going to dramatically change your R value of that section if the insulation isn't tight to the stud sides and to each other on the seams. So I always make sure that I have a nice horizontal line. Now, for stapling, I am using the Delta 20 volt stapler, and this is an absolutely wonderful tool. It's brand new. Ask your inspector whether or not they're going to allow it on the project. Mine did, and it comes with these sticks of staples. And the beauty is, obviously it's mechanical, so you don't have to be hammering, and it fits into really tight places. But it automatically adjusts the depth based on the size of cable that you are stapling. And I have no idea how it works. There's obviously something in the mechanism that it can sense between how far that's pushed back and whether or not that is on the surface that you're stapling to. And it is designed for, I'll just give you an idea here, single and double cable of 14.2, 14.3, 12.2, 12.3, even 10.2, it's designed for a double stack cable. Once you get up to 10.3, which is the maximum it can do, you can only use a single cable. That's its limitations. This is all for copper, and it's like I said, it's a wonderful tool. Obviously the staples are more expensive than the metal ones that you hammer in, but you save so much time. So for instance, I've got a 2 conductor and a 3 conductor, and it's just simply a matter of deciding what I want on top, what I want on the bottom. It's going to automatically turn on the light when it senses that it's in a good spot. Done. And you are finished. This plastic, call it sleeve, is not meant to go to the stapled surface. All it's there for is to prevent chafing from the sheathing on the cable to the metal on the staple. Now, let's talk about movement. A lot of forums where I looked at various electrician comments, they did not like this because it doesn't tightly staple the cable. It's not supposed to tightly staple the cable. It is actually against code to have a staple so tight that the cable does not move as it's doing here. If you staple too tight, you are propagating a stress point on the cable, on the conductor at that point, which can overheat and eventually lead to a fracture and a failure. So you're actually supposed to be able to move your cable in and out of the staple. And one of my first inspections I had with my inspector while I was doing my rough-in for the soffits, I needed to close in the soffit, so I had him come and look at the cabling I had done. And the first thing he checked was, he said, okay, good, you haven't overdriven your staples. Now, at that point, I was using the standard metal staples. I didn't have this beautiful beast. But he said that was the #1 thing that he looks for. So anyway, let's just, again, in BC, I think it's every 56 or 58 inches that you need a staple. So technically I could have one at the top, but to provide a little bit neater, I'll just put in an extra one. And that does provide, it allows the movement. It's still going up and down without chafing, but it keeps the cable in a spot that I want it. Now the reason that you want it, there's 2 reasons to allow it to move. One is, as I said, you don't want a stress riser created. You don't want to overly compress that copper inside the conductor. But you also want flexibility. The whole point of the staple is to hold the cable in the general location in the stud bay so that it's free from mechanical damage of things being attached to the wall on each side. And the reason, the second reason you want it to be flexible is if you drive a nail in or a screw in here and it starts to miss, the cable will move out of the way. If it was super tight and it couldn't move at all, you would end up scoring the outer sheathing and most likely the inner conductor sheathing and hitting the copper. So that's some of the tips that or tricks that I've picked up from Inspector and online research. Building science is where I get this information from. And as you can see, it's super easy to use this tool. Ask your inspector whether or not he's going to approve it. It is brand new, so it's not necessarily common anywhere, and the inspectors might not be used to it, and therefore they might not approve it. But fortunately mine did, and I absolutely love it. I will talk to you again soon. So here we are in the basement, and I'm going to talk a little bit about this lovely Leviton panel. So as you can see, we have been putting some circuits into it. On the previous video, I think when I talked about receiving this, it's a 66 circuit panel, and I'm using 64 circuits, all that are allowed. So I've got some before and after photos showing a different wiring style. I initially did it the way I was taught quite a while ago, where I allowed a lot of extra slack in the conductors coming into the panel. And if you go on the internet and you look at if you search for a Leviton installation photos, you'll see some that are military style, like aircraft style neat. I'm not quite there. I'm a little bit disappointed. I was trying, but I'm just, it requires some planning. I should have started from the bottom and worked my way up to the top. And instead I was doing just circuits based on the ease of running them. And fortunately I stopped that. I was about to start doing some of the high amperage circuits, which are at the top, but I really need to finish all of the 15 amp circuits coming into here first. So basically some of the stuff that you'll see on the net is that each black and white have a very short path, and they're very neatly tucked into the connectors for the circuit breaker. And this is a great system, being able to wire this up independent of the circuit breaker. Not having to try to wire up the circuit breaker and then slap it into place. This makes wiring up immensely easier. I've done a little bit of fancy, I've got a little system that I developed for the bonding conductor on both sides. It's fun, and it allows it to transition so that it'd be impossible to get it in that side. So it keeps it tight against the wall until it actually has to be connected. I used what's called Arlington's push connector right here. I bought a box of them. I didn't realize when I bought them that I also needed 1/2 inch. I wasn't thinking about the knockouts of the panel, but they're just not as nice to use. They're not as easy to get the cable in the right position and to get it nice so that you don't have excess outer sheathing showing through. Now, talk about these knockouts. They are not your average flimsy metal knockouts. It feels cast. It probably is, but it almost feels like it's cast steel. And to knock out, I'm going to put you down again, see if I can do this without dropping anything. There's no way that you're just going to carefully tap this thing and not. So, like I said, you're not going to be pushing this out easily like you do on a metal box. So the habit I've got is, and I don't have the specific screwdriver with me, I use a little screwdriver, but you basically pound it and it snaps off. And this has got the weight of, it's heavier than a toonie. It's got the weight of like a silver dollar. It's quite substantial. It's a very well-made panel, and mounting it was a breeze. I'll show you here. I'll get a better close-up in a sec. Put all this stuff down. So they have these keyholes, top and bottom. So once you've figured out, you can measure from the top of the cabinet down to the keyhole. You know that this has got to be at the required code height, which is, I don't remember what it is, 57 inches or something, 67 inches, I can't remember. From the ground, the floor, to the top of the most upper operable breaker. There's a code requirement. So you figure that out. You figure out the distance from here to here. to the top and then down to the keyhole, and you just basically put a small screw in there and you hang this on. And now, sorry, little bump there. Now you just put a level on it, level it off, and then you start putting your 4 screws in. And then you're supposed to take out the screw for the keyholes. It's a really neat system compared to others that I've done before. Now with 66 circuits, it's going to get crowded. Sorry, this is not acting properly. Bear with me a sec here. That's better. I had the gimbal on the wrong setting. I still have it on the wrong setting. Bear with me a sec here. I might be running out of battery juice. That's better. So I was about to say, it's starting with 66 circuits. It's starting to get a little crowded. I mean, this is a non-bearing wall. It's just a partition wall in the basement. I made the opening as wide as I really could based on the location. But I've got a limited amount of space here for all of these cables that are coming in. All of them are double stapled, so they're doubled up on each other, and this stapler allows for that. But I'm still going to run out of space. So the only way I thought to allow for this is to double up. So basically, I'm placing a plywood sheet there, and then I'm going to have a second layer. Hopefully the inspector is going to allow this. I don't know for sure. I'm taking a bit of a chance, but really, what choice do I have? You can't backstab this, so I can't come in from behind. So I can't build out the back side and have extra. There's always going to be a set amount of space that you've got here in a normal house, and bringing in this number of circuits is, like I said, it's crowded. So we'll see if that works. I've tried to be as neat as possible. I do have one rat nest in the house, and it's right above the panel, and that irks me. It got away from me. I tried to have it nice and neat at the beginning, and now it's just, like I said, it's like when you cast out into the river with your casting spool, and the line keeps on going out after the lure hits the water. And it's what you get with a whole whack of monofilament. Anyway, unfortunate, but it is the only place in the house. Generally, it's been quite neat. So I'm at a Leviton load center, and this is not going to be used as the service equipment. In other words, it's not going to have the main line coming from the electrical meter. That's going to first go to a service rated transfer switch. So it's important to remove the bonding between the neutral and ground bus. And so there's a screw here that I've taken out already, and then another one here. And that removes the bonding between the two, because that is only supposed to exist in the service equipment, where the ground is located in the service equipment, and then the rest of the system becomes bonding. So that is, I believe, all that I can report on. I've got a lot more work to do. I thought that I was close to complete on electrical as far as what I call switch down. So everything, all the cables from the switches to the plugs and down. But then I went through the final plan and ordered all the rest of my boxes, and I'm nowhere near complete. I've got a lot to do. Now, some of this includes stuff that I hadn't originally planned on, or isn't technically electrical. These plastic boxes will generally be used for the smoke detectors, carbon monoxide detectors, that kind of thing. And I'm also, I talked earlier about the multiple code cycles that I'm behind on. I had originally planned on not wiring up the basement now. the shops and whatnot. I was going to do that after we moved in. But that would mean that I would be under the newer code cycle, and that would just be a nightmare for the inspectors. 2 different code cycles, dramatically different requirements between code cycles, and the inspector's been patient with me. I just didn't want to do that to him. So it means that I am going to have a lot more electrical work than I planned on. It's going to put me further behind schedule. I had hoped to be in by late August, and then late September, and then late October, and now I'm just going to do my best to be in by Christmas. It should be possible if everything goes right, but we will see. Nothing tends to go right with me. I'm my own worst enemy, and that's just something that you learn as an owner-builder as you go along. But anyway, that is that. Got all of the smoke detectors and security system stuff ready to go. Been purchased. I got a great deal from Kitty. They gave me a great deal online. They gave me a good discount code to use when I checked out, and they also gave me great customer service in choosing the right alarm. I have a lot of dusty areas, and for dusty areas you don't want photovoltaic, or sorry, photo. You want ionization. But then the difference between ionization and photo something is how they detect fires and how good they are at, compared to, say, detecting a smoldering fire versus something burning vigorously. And so what you really want is you want dual, which I have for a lot of areas, but in the dusty areas, what I really needed was ionization. And so I was able to find the appropriate ones for, say, the shop area and that kind of thing. That's it. Again, sorry for the update and sorry for the length of this post. I guess that's what happens when I go month between updates, and lots has happened. Thanks for visiting, and we'll see you again soon.